We're in the middle of winter here in Northwest Indiana, and with that, all sorts of interesting weather can happen.
So today we're going to tell you all about that interesting weather as well as what you can do to keep yourself safe. You're watching the Cold Front here on VUTV.
Welcome to the cold front. Now we're into the second semester. It's time for winter weather. And when you think about winter weather, probably what's coming to mind is what you see right behind us. All this snow, snowman, all these pretty pictures that come into play. And obviously snow is a huge factor when we start talking about winter weather, about safety hazards and everything. But we're going to jump in a little bit right away to what we kind of forget about, and that's the extreme cold and the winds that oftentimes are associated with that. In fact, you hear people talk about the wind chill and what the wind chill is, and obviously you see some really, really cold temperatures in it. You know, it's essentially the feel-like temperature, but why is that, you know? The wind actually is what's going to happen is when it's really windy and cold, the wind actually pulls heat away from your body, so it directly affects you. The wind chill does not affect things like plants, though the cold temperature that's probably associated will take care of them.
Yeah.
But the wind chill is specifically towards humans and animals, of just pulling the heat away from the body, and it can make you colder much faster, and frostbite can really set in, and that is a major player once we start getting into these real dead months of winter, like February and January, where it starts getting extremely cold.
Yeah, and there are even times where it only takes about 30 minutes for that severe frostbite to set in, and that's around when the wind chill is around -18 degrees. So that is obviously a very, very cold temperature, but if you're outside for 30 minutes or more, that's when that frostbite could set in. But as the wind chill gets colder, it even takes less time. -32 for the wind chill, it only takes 10 minutes, and then -48 for the wind chill. It only takes 5 minutes to set in. So if you are someone who has to work a lot outside during the winter, you definitely have to pay attention to that wind chill, because it can cause a huge factor with not only frostbite, but it can cause severe hypothermia. It can cause very, very problematic health issues. And a lot of people who do work outside, you know, for the winter, whether it's farmers or construction workers or anything like that, and they have to bundle up and they really have to pay attention to those weather forecasts, and especially the wind chill, because like you said, it can have a very detrimental effect to a lot of people.
Yeah, and that wind chill and those numbers, when you were mentioning them off, they're extremely cold, but we want to remind you those aren't that uncommon. Even down here in Indiana, that -18 wind chill, we've already seen it twice this winter here in Valparaiso and places further north, even into, say, the northern half of Wisconsin and northern three-quarters of Minnesota. These wind chills are
very common.
Fairly common. So, especially way up north, say Minnesota, Upper Peninsula, they've already seen the wind chills where it's been 5 minutes to frostbite, and that's almost to the point where you're going out to check your mail or get your paper at your curb. So I mean, you really have to be careful. It can set in extremely fast.
Yes, it can.
So I mean, a lot of that, I mean, minor frostbite, you're always supposed to go and get treatment if you get frostbite. But the biggest thing that you can do yourself when you're on your way to get treatment, if you catch yourself in that, is the first thing that medical officials will tell you to do is you have to warm the area up, put it in warm water, and then get yourself to a doctor as fast as you can, and they can help with the rest of the healing process for the best chance of survival. Even for the smallest amounts of frostbite, it's a very serious issue. I mean, I have friends that work outside. I work landscaping in the summer, and those same guys are the guys plowing all the parking lots in winter. And some of the crews go out and snow blow residential places, and those guys have to be really careful because they're out in the blizzards.
Yes, they are.
Doing all that stuff. Yeah. And don't forget about your letter carriers, your mailmen, walking from door to door outside. I mean, that was always their motto, rain, sunshine, snow blizzard, they're out and all.
Yes,
And
they are.
that's not the best thing to do. So they have a real tough job, and they know how to keep warm. But again, that minus 18 where it really starts frostbite, it comes into the picture, is not that cold actually. And furthermore, you can get that, and I mean, I like wearing shorts, I'm a guy, I love my shorts. I'm from Wisconsin. Sometimes I put on the tough face and wear my shorts when it starts getting cold. Once these wind chills start getting down there, I mean, I know when, it's time to bundle up because it's actually dangerous for me. So don't try to tough it out.
No.
You can't. I mean, it's scientifically impossible to tough it out. I mean, this is science here. It's just that the wind chill charts are available on the National Weather Service website anytime you want it, and of course showing on your screen right now as well for reference. But again, you can get that at the National Weather Service website at any time.
And the best thing to do is, if you do have to go outside and work, as we've been talking about it pretty much this entire segment, is make sure you bundle up. Put a lot of layers on. If you have thermals or long underwear or something like that, make sure you put them on. You have gloves on, put gloves on. They do make little, what are they called?
Hand warmers.
Hand warmers, and you just stick them inside your gloves, and they help keep your hands warm. Wear a hat, put something over your ears. If a lot of your face is going to be exposed, maybe put on, a ski mask or wear your scarf up to your nose, because you definitely want to stay warm if you do have to go outside. If you're going outside for a short amount of time, you probably don't have to put on quite that much, but you do want to stay bundled up. Put on your jacket, put on your scarf, put on thicker socks. You want to make sure you stay as warm as possible, so that way you're kind of safe from that wind chill value, so you don't have to worry about getting frostbite.
And I think that everyone remembers this back from when their mother was talking to them, and I can hear my mother saying that exact same stuff to me from years ago. But even less obvious than that, if you're traveling by your car and you think you'll be fine because you had heat, you got to make sure you have everything just in case you get stranded. Make sure you have like a safety kit. Make sure you have enough warm clothes just in case, because if you have to go outside, maybe you get a flat tire or something, you want to be ready. Have gloves, have a hat. Even when you're inside your car and you think you're safe from the wind chill and the cold, you're never quite sure. And we spent a lot of time talking about the wind here and the cold, but let's dive into some of that snow stuff. This nice white stuff that really can make a lot of pretty pictures in winter, but can make roads and walking conditions absolutely treacherous.
Definitely. So the most, I shouldn't say common, but when we think of snow, we think of snow on what's called a synoptic level. That basically means it's a snow event that's formed by a normal low pressure
It's just
system.
this large system that affects a large portion of the country, and it's just these big systems that move through, and different amounts associated amounts of snow occur with them.
Definitely. And so, like, for a synoptic level snowfall, you usually have just a low pressure system, but it has to move down to the south of you. It can't kind of move right over your area. It has to move down to the south. And I believe you have to be in the northwest sector of that low pressure system in order to have the best chance for some snowfall. And as with most systems, it depends on what it's like as the higher you go up in the atmosphere. So around the mid-levels, it has to be below freezing. It has to be around -2 to around -4 degrees Celsius. So just a couple degrees below that freezing point. And then obviously 32 degrees or below here at the surface. And then you get the possibility for that snow.
So basically what Rachel was just saying is, as opposed to summer storms where you hear the words like the cold front that causes the big storms, and that usually occurs on the southern side of the center of the system that moves through. In winter, the most snow, of course, happens on the north side of the system. And what she described was those big systems that drop that heavy, wet snowfall when the temperatures are right. Of course, when temperatures aren't, that's when things can get really messy, and you can get ice storms and mixed precipitation and sleet and all the stuff that's really not fun. I don't know anybody that enjoys sleet and ice storms because it's not even pretty. It knocks out power.
No.
It's real bad. But when that snow, the temperature's right and you're gonna get snow, The most snow is actually going to occur almost 100 miles and even a little bit further north of the lows, where that heaviest snow bands are going to set up. And because of the way the low is going to be tracking, you're going to be hit with that heavy band if it sets up over you. And that's where you can see the 12-inch plus snowfalls. The other type of systems, as opposed to those big storms that come in from the south moving up, are what's called Alberta clippers. And that's because the storm kind of originates, it comes from the province of Alberta in Canada. And it pretty much comes up from the north and mushes down through the area and drops snow. Usually not as much snow because the air up in Canada is much drier, so it doesn't hold as much moisture, and the snow is that more powdery stuff. And those systems, when they're stronger, can drop maybe up to 6 inches, maybe a little more, but generally a quick couple inches of dry snow is what you get from those clipper storms.
Yeah. And when you do have those clipper systems, that's actually what causes some rain and even the possibility of some storms down to the south of us as well. Because obviously they're getting a little bit more moisture from the Gulf of Mexico than us, who are a little bit farther north, are getting the results of that Alberta clipper. And so they're getting a little bit more moisture, they have a little bit more warmth. And so when that cold front from the low pressure system hits them, it could bring the possibility of some thunderstorms and some rain. People are always talking about, oh, it's storming in January or it's storming in February. We've never seen this before. It's actually quite common, and especially farther down to the south, it is very common to see that.
Yeah, that's something that really amazes me as a meteorologist in training, is these systems that on one side of the low, on the north side, can drop on a really strong system 18, 20 inches of snow. And 200, 300, 400, 500 miles south, suddenly there's severe weather and tornadoes. And it's just absolutely amazing to me that this same storm that's causing all the snow, say up in Wisconsin or Minnesota, is dropping tornadoes in Arkansas and Kansas, and it's all the same big thing, and that's just really cool. But now on a much, much smaller scale. We're right on this big lake called Lake Michigan, and it happens on all the Great Lakes, and there's even some smaller lakes that can get this lake effect snow. And lake effect is different than, say, this large scale systems that move through, and it's actually driven by temperature difference between the lake and the land. The lake is going to be much warmer than land because water takes much longer time to change temperatures than the land does. So in winter, if that land gets really cold, say, low 20s even, and suddenly the lake temperature is still in the 40s or even upper 30s, now you got all this warmer air over the top of that lake that's kind of driven by the lake temperatures, and warmer obviously relatively, because we don't think of 35 degrees or 40 degrees as warm, but compared to the air that's blowing across the top of it, especially to get lake effect snow in Valparaiso, Indiana, is when the winds are out of the north. So the winds are going straight down the lake, and that's going to help push that warmer air across towards us. And that warm air is going to rise up, and when that warm air rises up, it takes that moisture that's also from the lake, and it can create this convective, actually, type snow. And by convective, what I mean is it's all driven by the heat transport upwards from the lake, and convection is the same thing that drives thunderstorms. So it's actually a very similar process as a thunderstorm to create lake effect snow. And that's where you get the really, really heavy snowfall that can drop a lot of snow in a very short period of time. However, the area that it affects is very small. The places, at least in our region, that gets the most lake effect snow on a broader scale will be western Michigan on the east side of Lake Michigan, where if the winds are out of the west, which is actually fairly common, you get a lot of lake effect bands setting up for that half of Michigan, and that's how they pick up almost most of their snow throughout the year, besides the big snowstorms that push their way through. So that's one reason that Michigan there will get a lot more snow than we do here in Valparaiso, Indiana.
And there are even certain parts of the upper peninsula of Michigan that not only gets lake effect from Lake Michigan, but they get lake effect from Lake Superior. So sometimes they get it coming off two different lakes and Lake Huron. sometimes they get off of multiple lakes at once. So there are some places that lake effect is basically the only kind of snow event that they get, but they're just in the right spot, you know, by all the lakes and the winds just coming out of the right direction.
A great example of that is Buffalo, New York.
Yes.
With how the winds come off of the lakes by them, they're just going to get a lot of lake effect snow where they're located. It's just part of where they are in the country, and it's a major driving factor into their winter. Well, when we come back from the cold front, we'll be joined by Dave Caulfield, and he'll help talk about nor'easters that affect the eastern half of the country. Stay tuned. You're watching the cold front here on VUTV.
Hi everybody, I'm Dick Vitale of ESPN, and I'm on VUTV. It's awesome, baby, with a capital A.
I'm Brandon Spinner, and I'm on VUTV.
I'm Lisa Meadows, and I'm on VUTV.
We're Women's Ultimate Frisbee, and we're on VUTV.
I'm Tristan Leonard, and I'm on VUTV.
We're Men's Ultimate Frisbee, and we're on VUTV.
Hi, my name is Nicole Graham. I'm an admission counselor here at Valpo, and I'm on VUTV.
We're Air Force ROTC, and we're on VUTV.
We're Mock Trial, and we're on VUTV.
And welcome back to the cold front, talking all about the winter weather and types of storms we can see in winter. And we're going to expand it out a little bit. I'm joined by Dave Caulfield here, our resident East Coast expert. We're going along this, and we're going to move to a type of the larger scale storms that we were talking about, specifically the nor'easter. And Dave is going to tell us all about the nor'easter and why do we call it a nor'easter?
Well, Matt, it's because it's not because it affects the northeast of the United States. That's a common misconception. It's actually named for its northeast winds, excuse me. Now, what happens is usually nor'easters occur in about September, October, but they can occur as late as April, as we saw last year. I did a story on that nor'easter that affected parts of western Pennsylvania and West Virginia, and really all up the east coast, and gave them heavy rain and lots of snow in those mountainous areas. But they usually happen September, October, because that's when you get the cold air necessary for these storms. So what happens is there's cold air ahead of the storm in places like Massachusetts, New England, all parts of New England, and even into parts of New York and New Jersey. Now, that cold air is not allowed to expand, so it packs itself in. It's very dense. And what happens is if there's a storm that comes in and it feeds off that cold air, that storm can't expand, right? Okay, so you with me so far? Very good. All right, so that storm will go and hit the ocean. Instead of going offshore, it uses the ocean to feed off of that energy. And that ocean air is much warmer than the storm, relative to the storm, that is. So it allows the storm, or the ocean waters allow the storm to gain energy and sort of spin up like you would expect with a hurricane type of storm, but it still has that mini circulation to it. That's why a lot of nor'easters appear to just be monsters spinning counterclockwise and really just affecting a lot of the East Coast. Now, pulls the warm air from the ocean. There's strong winds associated with that storm, and the way that the nor'easter comes in is it pulls the winds and shifts them to the northeast, and that's how we get that name.
These storms are really strong, and that's part of why not only is it those winds, but they get so deep in what we call the low pressure. The pressure can get so low in that because they're not allowed to expand, that pressure changes really fast in a short distance. And what that basically means is the winds go really strong across that area. And as Dave mentioned too, they're coming out of the northeast at that super, super strong speed.
Right, and we've had a lot of nor'easters recently, especially in portions of New Jersey, and even on up. You know, they can affect a lot of the East Coast, not necessarily where I live, but as well as north and south of New Jersey. In portions as south as Virginia, North Carolina can get some snow out of these, and as north as Maine, obviously. Now, excuse me, the most famous nor'easter type storm over the last couple of years has been Sandy. And the reason why I call it a nor'easter, not a hurricane, was for a long time it was a hurricane when it was over waters. But what happened was, it's kind of difficult to explain. It became an extratropical hurricane, we like to call it.
It basically converted from a hurricane into the type of cyclones the type of storms that create our snow and our normal winter weather systems. It basically moved far enough north that it became that type of storm.
Yeah, absolutely. And what happened because of it, during that transition from hurricane to just regular old storm, it wasn't a regular old storm because it had hurricane size and speed to it. So what happened was it came on shore and it really devastated the coastline of New Jersey, still affected by that today. And what really affected areas even more inland, such as Pennsylvania, even to our area, we got some effects from Sandy, was it just sat there. It sat over Pennsylvania and really just all that rain got in there, a lot of flooding inland, and the wind was a big factor as well. It finally moved up the coast and got into Canada and then offshore eventually, but still, that really affected portions of the Northeast more than most people will ever know. They're still going to be recovering from it 5, maybe 10 years down the road. So definitely a big storm there. But the classic nor'easter that we're used to will come up over Florida and really, as I said, gain some of that energy from the ocean and kind of turn inward. Depending on where it turns inward is depending on whether you get a lot of snow or not. But if it turns inward at just the right time, you get all that moisture from the ocean as well. You can get somewhere up to 2 feet sometimes, especially at my house. We had 2 feet one time, and I could barely walk outside to shovel, and that was not fun. But it's still very interesting to see. If you hear about nor'easters coming, you know, they may not always affect you in Indiana or in the Valparaiso area, but by me, they're definitely a big deal. And getting back to...
but they can... Because they're up on the East Coast and blocking, a lot of times you might not be feeling the effects of the storm, but it's affecting, in fact, global weather patterns by just sitting there.
Oh, yeah. I mean, people, you know, we're so used to saying there's a high in place and that's blocking weather around the area, but lows can do that as well, especially nor'easters with their size. And, you know, in Indiana, we may, Indianaans maybe feel Hoosiers. There we go. I'm sorry. They may be feeling the effects of maybe nice weather behind that nor'easter, or maybe some rain off of that. It all depends. Now during Sandy, this is what I was going to say before. Even though we didn't feel a lot of rain, we definitely felt the wind off of that cyclone coming just straight off the lake, north winds, because of where that cyclone was positioned. And we went to the dunes that day, and we saw upwards of 20-foot winds and gusts of 40 miles per hour or more. 20-foot waves, excuse me. I had winds on the mind. Yeah, they were absolutely...
But driven by the winds.
Exactly. Driven by the 40-mile-per-hour plus winds. And those waves were absolutely gargantuan and really were a sight to see. I'm definitely glad I got to go on that day. My jacket still has sand in it from all, and it's an apt name, Sandy, because I have sand all over me. Yeah, it still has sand in it because of those winds just whipping. And we tried to do some camera work there, and it would have helped to have a you know, like a little bit steadier tripod, but still, those
wasn't much it could do. I was behind that camera. Not much it could do.
And I mean, you could barely hear us with the winds just whipping, and we were right next to the camera too, and you couldn't hear any of it because of those winds off of Lake Michigan. So not always just affecting the Northeast. The Midwest can get effects from a nor'easter as well.
Yeah, and along the lines of those really strong, deep, low pressure systems, something that can happen a little closer to home, bomb cyclones is what we call them. And they are normal big storms that affect us, but they get really strong, really fast. In fact, we had one just a couple of years ago, October 27th, 2010. It was more of the effect of the snow side and the big strong winds up in Minnesota and Wisconsin. However, it affected weather all down the coast. In fact, severe weather reports, tornadoes. In fact, Porter County, Indiana had an EF0 tornado touch down because of this storm.
Yeah, and LaPorte actually had an EF1. Total tornado reports from this gigantic system, which some people call it the Landicane. You know, there are a lot of names for this bomb cyclone, as we call it. But LaPorte had an EF1. There were 69 tornado reports in total. And really, this storm was a monster. We had 953 central pressure, 953 millibars. And if you're not familiar with millibars, it's and you are more familiar with inches of mercury, I believe it was around 28.11 inches of mercury.
And our normal values that we would expect to see in a strong cyclone, say a strong storm, might be, 990 millibars. We're talking, 40 millibars less than that. Yet in high pressure would be about, 1020, 1030. So that's a huge difference and huge deviation from the normal.
Oh,
extremely strong.
Absolutely. And I mean, in the weather department here, if we see a storm that has 9.8 something on the millibars, we take notice. And that's way different from a 950. 950s are absolutely enormous and nothing to be messed with. And so all those tornado reports came off of that cold front, but Minnesota and even into portions of Green Bay and south of Minnesota, they got the brunt of that storm. Not really the cold front, but really just the center of that low sitting over them. And Chicago did get impacted as well, as we saw, but it was more of a Minnesota and Northland storm. Now, we had 78 mile per hour gust maximum, and for a mid-latitude cyclone, just a regular old storm, that's actually the threshold for a Category 1 hurricane. So definitely some very strong winds. Now, we talked about strong waves on Lake Michigan. This storm affected Lake Superior. We had 19-foot waves. Let me get waves instead of winds, right? 19-foot waves on Lake Superior on shore. Now, the max was 27-foot waves. In the buoy in the middle of the lake recorded that 27-foot waves. I mean, I'm not a surfer, but I wouldn't even go and touch those waves. They are so high.
Wow, that's just a large amount. That's insane.
Yeah,
and the winds were the big story with the storm. It did drop snow. In fact, I believe St. Louis County in Minnesota recorded 9 inches of snow. So a good amount of snow, not an insane amount of snow, but a good storm. But think about the blizzard conditions. Blizzard conditions, they're not always with a lot of snow, but it's how fast that snow gets driven, and it's all about visibility. When visibility is, below 1/4 mile,
right,
that's your blizzard warning when it's caused by blowing snow. But so think about the snow falling and being whipped by those winds, which probably around that area, maybe not at the full 78 miles an hour gust, but even if they're running at 40, I mean, which is probably a fair assumption, almost half of the top gust. That is an absolute blizzard condition, and I can only imagine how much that affected travel.
Yeah, and you bring up a very good point, Matt. A lot of people, when they hear the word blizzard, they think it's going to be the storm of the century, and everything is going to be thrown at them from the weather, including the kitchen sink, which doesn't happen, by the way. But
well, it can happen in tornadoes.
Exactly, but those are very rare cases. However, a blizzard doesn't really have to do with the amount of snow, as Matt said. It has to do with the wind and the visibility. If winds are over, I believe it's 40 miles per hour, definitely, if they're getting up there in terms of speed, but the visibility is the most important. Under 1/4 mile, that constitutes as a blizzard. Now, and that way, travel is impaired tremendously, and you really can't get anywhere. You really can't see in front of you, basically, and the wind will be whipping that snow at you so hard. So, I mean, this was definitely a very interesting case. We don't see these very often, especially over land, because, bomb cyclones, even though they are over land, they take some hurricane type features with them in the fact that they go,
which is how strong they get.
Exactly. They get so strong as that, and they lose, or they decrease in pressure very rapidly. The threshold for a bomb cyclone is 1 millibar per hour for 24 hours lost.
And that's how we define it.
I can't define that in inches of mercury because I don't really know what those are, but that's all right. It would definitely be a precipitous drop in pressure over 24 hours. So definitely a very interesting case, especially for portions of Minnesota.
And Dave, you did a good job of teasing ahead there. When we come back after the break, we're going to break down the safety aspect, going over all the National Weather Service products and stuff for winter, including the blizzard warning, which is probably the top dog on that chain of warnings. So when we come back, Rachel will be back, and her and I will go over all this stuff here, watching the cold front here on VUTV.
Are you looking for true love? As a matter of fact, I am. Well, have I got news for you. Put yourself in the capable hands of our expert matchmaking team.
Hi.
Tell me more. The Torch and VUTV are teaming up to send a few lucky couples on a romantic blind date this February 12th. How do I sign up? You can sign up in 2 ways. First, sign up online at valvotorch.com or on VUTV's Facebook page to fill out our Love Compatibility Survey. Second, you can sign up in the Chapel View Lounge at our table during chapel breaks, January 28th to February 8th.
I'll go now.
Calling all lovebirds, are you looking for a mate to share your nest with this Valentine's Day? Let the Torch and VUTV help. You can sign up online at valpotorch.com or on VUTV's Facebook page and fill out our Love Compatibility Survey. Or find us in the Chapel View Lounge from January 28th to February 8th. Catch you there, Crusaders.
I'm Mitch Dunham, and I'm on VUTV.
Hello, I am Jeremy Kaywood, and I'm on VUTV.
I'm Jonathan Johnson, and I'm on VUTV.
We're Sigma Phi Epsilon, and we're on VUTV.
Hi, I'm Claire Flesh, and I'm on VUTV.
The Valparaiso University Meteorology Program gives you the scientific knowledge of a big university while keeping the small college atmosphere. At Valpo, you have the opportunity to take meteorology courses every semester throughout your college experience. Our approachable faculty are among the best in their field, and the small student-to-professor ratio promotes individualized learning and a family environment. Valparaiso's extracurriculars encourage specialization in all aspects of weather, including research, operational, aviation, and broadcasting. Students receive hands-on experience forecasting, launching weather balloons, using our on-campus dual polarization Doppler radar, and even chasing storms. Our alumni serve in all areas of meteorology, from researchers at universities to forecasters at the National Weather Service to Good Morning America. Valpo Meteorology, your forecast calls for success. And welcome back to this winter weather episode of the Cold Front. Rachel Duensing rejoins me here. We've gone over basically what all the winter weather storms are, but now let's shift gears into the National Weather Service, what they do to help keep you safe. We talked a little bit about safety in our first segment of the show with what you should do for the severe cold to keep yourself safe, but now this is what the National Weather Service, how it helps to relay to you how to keep safe. So let's go right into what type of products they issue.
Well, the first one we're going to talk about, Matt, is the winter weather advisory. There is no winter weather watch or warning. It just kind of goes straight to an advisory. And when you get an alert that says, oh, National Weather Service is issuing a winter weather advisory, basically what that means is that they're forecasting for 3 to 6 inches of snow for that area that's in the advisory. And the reason they do that is because, obviously snow is a huge, has a pretty big effect on travel, and especially at that 3 to 6 inch point is where it can really start affecting travel conditions. People are out on the road driving, people are walking, anything like that. And so that is why they issued that advisory, and it's I think it's a very good idea that there's not really a watch or warning. It's just kind of like, hey, you need to be a little bit aware of this, that this amount of snow can cause some issues, especially for travel.
Although with that wording, I'm a little bit confused on why the winter weather just has advisory, and then there's the winter storm, which has watches and warnings, and essentially it's for the same type of deal, just a little bit more significant. The winter storm watches and warnings are issued when severe winter storm conditions, including heavy snow and ice with reduced visibility, is expected. And their basic criteria that the National Weather Service sets out for this is 6 inches or more snow falling within a 12-hour period, or 8 inches or more in a 24-hour period. So the watch obviously is a little further out and more long-term, kind of look out for this, watch out for it, it's coming up, and the warning is, hey, this is starting to happen now or very soon, you need to take cover. And that's what the whole point of the watches and warnings and advisories. I know that's all confusing to everyone, but again, it's winter storm warning is the severe winter storm conditions are going to occur, and it's not quite at the blizzard stage yet.
Right. And the blizzard is basically the kind of covering all bases snow event. It's the blizzard is a little bit more of a severe weather sort of advisory, and they do issue blizzard watches and warnings. And basically what constitutes a blizzard watch or warning is if they're either forecasting or the snow is causing reduced visibility to 1/4 of a mile. So very, very reduced visibility, whether it's snow that's already fallen or snow that is falling, with winds that are sustained at 35 miles per hour or greater, because obviously that wind will either blow up the snow that is already fallen or that is falling and will cause that reduced visibility. And it's kind of like what you were saying before, you know, the watch is, we're forecasting this, you know, we are expecting things to get this bad. And then the warning is, this is happening now. You need to, you know, be aware that there is reduced visibility. There's a lot of snow that's blowing around and it is causing a lot of problems. So maybe you should stay inside or find other means of transportation if you do have to go somewhere.
Yeah, the blizzard of the advisories, watches, and warnings in the winter weather category, it's really the granddaddy of them all, to put the football reference in there.
It's a good way to put it.
It's the biggest one. It's the most impact. If you're under a blizzard warning, there's a good chance that you're going to be inside your home for a couple days with just a lot of snow, not necessarily, but that visibility from that blowing snow is going to drop way down. It's going to be extremely hard to travel. In fact, even in some cases hard to see when you're walking 10 feet in front of you. So going outside, even your front porch, is dangerous in blizzard warnings. The next step one is, if the temperatures aren't quite warm enough for snow, you can get an ice storm. And that's when it's just raining and freezing on the ground and sleet and all that stuff, and it just freezes and accumulates. And we're talking 1/4 inch accumulation is the requirements for the watch warning on the ice storm. Now, 1/4 inch, that doesn't sound like a lot, but when we're talking about ice, 1/4 inch of ice is a lot. And not only is it going to just be on the roads, it'll stick to the power lines, it'll stick to your house, it'll stick to your cars, it'll stick to you if you're walking outside.
Yeah.
A little bit. It's going to just be freezing everything over, knocking power out. We don't see that a lot here in the Northwest Indiana, more in the transition seasons if we're going to see it. But down a little bit further south, even central Indiana and south, and that's where it's seen a lot, where it's not quite cold enough to snow, but they get this icing. And that happens a lot down there.
And the problem with ice storms is that it's like you said, it covers everything. So it can bring down those power lines, it can bring down trees, cause, you know, power outages like you were saying before. It can also cause damage to your homes and to any buildings that, you know, you may have if you have like a garage or some sort of outbuilding. It can definitely cause damage to that as well, because that ice is very heavy and it can cause those pretty big problems. But something else that can cause a lot of problems we talked about in the first segment is wind chill. And National Weather Service does actually issue wind chill watches and warnings. But the thing about those is the criteria for those kind of vary from office to office. So here in the Chicago office that affects Valparaiso, the wind chill watch criteria is when the wind chill will be around -15 degrees, and then the criteria for warning is right around a -25 degrees for that wind chill. But there are places in like northern Minnesota that their watch criteria may be -25 because they're a little bit more used to it, because in the northern plains they've been experiencing a lot of wind chills lately, and they do experience a little bit more often than we do here in Northwest Indiana and in the Midwest. And so that is something that it's a little bit different than most watches or warnings, because the criteria does vary a little bit from area to area.
Yeah, and that is very interesting. But if you think about going way up there and way up there in northern Minnesota and northern Wisconsin and the UP, they're much more used to of that cold weather, and it happens much more often. So the people there are used to it, so they don't need to be warned like we do down here for the -15, -25. So that's why the criteria changes. But either way, the impacts stay the same as to how much caution you should be taking. Right. Are you confused? We go through this a lot.
It's okay if you're confused.
The Weather Service has been struggling for this for years on getting people to understand all these watches and warnings and advisories. The public doesn't always know the difference between a watch or a warning, and that's a problem. And the National Weather Service is taking blame for that, and not just the National Weather Service, the entire weather community is taking blame for this. And the National Weather Service, after doing some studying, has decided that they're going to test out a new wording system for their advisories, their watches, and their warnings. And they're testing it out in parts of the country, not the whole country, in fact, less than half of the country, in areas such as I believe all of the lower peninsula of Michigan, North Dakota, South Dakota, Montana. There's one area in Tennessee, a couple on the East Coast, Alaska, and actually Honolulu for the upper mountains up there. They can get some winter weather up there.
They do on a pretty regular basis, if I remember correctly.
So they're changing warnings, and they're trying to get their message across. If you don't know what their messages are, a watch means that there's a potential for something to happen in the future. An advisory is when you should take caution for something. It's happening now. It's not necessarily of major impacts, but if you don't take caution, you could end up in an unsafe situation. And a warning is when there's a very dangerous system that if you don't stay inside, you don't take cover, you don't stay out of the elements, you are in immediate danger. So the new wording that they're testing out in these areas, and they're going to evaluate how the public responds to it, are as follows. For a watch, they're going to say the National Weather Service forecasts potential for, and then whether it's winter storm or a blizzard or whatever. For an advisory, they're going to say the National Weather Service advises caution for the situation. Now for warnings, they're still going to use the word warning because they really like that word. The public understands what a warning is. Sometimes the watch and advisory get lost into it. But they're going to say the National Weather Service issues a warning for a dangerous and then type of storm. Say a dangerous blizzard, a dangerous tornado, dangerous severe thunderstorm. And what they're hoping is it more directly communicates what's happening with the weather to what you should do. And that's their goal. And that's what they want to do. And we're very interested in getting this out as fast and as simply as we can. And I think there's a lot of good that's going on here.
I definitely agree with you. I think that, kind of like what we were talking about before, sometimes they do get a little bit lost in translation. Because I know we've talked about this before, as meteorology students, people ask all the time, well, wait, what's the difference between a watch and a warning? Again, I'm not quite sure if I understand. While for some of us who are, involved in it, pretty much every day, it's something that we're a little bit more used to. So I do think that the rewording will have a little bit more of an impact on the general public because they will be able to understand it a little bit more. And it's not necessarily getting less information out there. It's just getting it out there in a manner that may be better understood and in a little bit quicker way.
And I think part of this issue is where the National Weather Service lost some trust is back, say, in the 80s, even carrying into the 90s, especially with severe weather. Their forecasts were very good for the time, but wasn't as accurate as they would like to be, and they were building up towards better accuracy. In fact, in the last 10 years, with the computers improvements going super fast, our forecasts now are extremely accurate, and now they're to the point where the public should trust it because if they're issuing a warning, it's more than not going to verify, in fact, at very good rates, as opposed to 20, 30 years ago when the verification rates were nowhere near as good as they should be. So now we're at the point where our forecasts finally are good and where they're exceptionally accurate and very well, the warnings are being issued when they need to be and not when they're not. So, but we're still struggling with the loss of trust that we lost when we were over-warning in the 90s and 80s, arguably. So now the National Weather Service is trying to regroup, reword their warnings and everything so that the public can understand what they need to do when something's issued. And we're hoping that with much better verification rates that the trust will be earned back. And we're asking that everybody listens to their meteorologists, listens to the National Weather Service, because that even in the last 5-10 years and in the foreseeable future, our models are going to get so much even better, and that's going to only lead to even better forecast warnings.
Yeah, and that's definitely true. And now that you know about the differences between the watches, warnings, and advisories, hopefully you can stay safe out there in this winter season and as we can transition over into spring.
And that's going to do it for this edition of the Cold Front, all about winter weather safety. I'm Matthew Schaefer, and for Rachel Duensing and Dave Caulfield, you've watched the Cold Front on VUTV.